Alright everyone, Cody here. Welcome back to my laboratory. So this is the ongoing experimental algae panel project, which I've shown in a previous video. It's been running for about 5 weeks now. As you can see, the water is still green. The neighbor's house no longer eclipses it so early in the day. That's pretty nice. Neighbor's dog's gonna bark at us. Sorry about that. Let's open it up so you can see one change that I've made since the last video, which, the thermometer's battery's gone dead. Oh well. It's probably about 25 degrees Celsius. That's what it's been holding at. And if we open this up, you can see I've replaced the fish tank heater with a light bulb in a jar. This was recommended by the viewers. It's pretty sketchy, but it does work. You know, if I'm using 25 watts to heat the chamber anyway, it may as well be in a form that the algae can use. If it's cloudy for a week, that'll help keep the algae alive, warm and fed. You see, I've also got a toilet brush, which I did sanitize before putting it in here, to kind of stir it around and get algae that's stuck on the bottom to mix up into the solution, so that when I'm measuring the biomass, I'm able to get an accurate measure, because the flat bottom collects the algae. So that's the first change that I would like to make, is the next iteration have a cone-shaped bottom on the algae tank so that the algae collects to one spot rather than a wide area, and also stir it better. This bubble stone is just completely inadequate. But the biggest problem is the rotten smell that it started to produce. And because of that, I'm going to be shutting it down. Now, I've gathered all of the information I need. The algae mass measurements have been decreasing. It's actually losing mass. It's not actually growing more algae. So it's time to start over, I think. Another problem is, see this? Green icicles. Yeah, we've sprung a leak, which I'm surprised it lasted this long without making a leak. That's a lot of joints. Probably one of the bottles has separated due to thermal expansion or something. I expected that to happen. But the reason for the rotten smell is right here. See that algae getting caught up here? The living algae is dark green. The dead algae is a white or a light colored green. So what's happening is the algae is getting caught in all of these little grooves between the bottles. And then at night, when it freezes, that algae dies. The ice crystals rupture the cell walls and kill it. So every night, a little bit more algae is getting into the system and dying. And that attracts other microorganisms. You see, algae growers, one of the methods we use to combat other organisms is just to make sure the algae population is so high that it's able to multiply quickly enough and consume all of the available nutrients before something else can. But if the algae dies, that's free nutrients that another organism can come by and eat. So even though I did rinse the system out with bleach before I put the algae in, it's not a perfect system. You know, there's still a few holes. So other organisms are able to get in and just multiply, and it probably won't be long before the algae is just overrun. Another reason for the dead algae is this pump in here, which you probably can't see anymore. It's a centrifugal pump. It's got an impeller that spins around really fast, throws the water out fast enough that it's able to go up to this height. That's a very violent process. Algae is pretty resilient. I think if you're just pumping the algae from one tank to another, you could use a centrifugal pump just fine. But for continuous use, that's just too much. That's got to be bad for the algae. I imagine occasionally an algae cell gets hit by the impeller and it kills it. And over time, that dead algae is just going to accumulate and attract organisms. So I need, first of all, less places for the algae to get caught at night, and a less violent pump. Those are probably the two main changes I'd like to make for the next iteration. For the pump, I'm thinking an airlift pump would work. Those don't pump the water very high though. They're far more gentle, but there's a trade-off. So in order to get the water to be able to flow with an airlift pump, I'm thinking maybe the tank of algae needs to rise up to the level of the top of the panel so that it doesn't have as much pressure needed to force it through. Maybe have it inside of like a bigger tank of water and then pump the water with the centrifugal pump, like pump it into the chamber and then have some floats on the algae tank that would lift it up. I think that'd be pretty cool. Another thing is I want to pump the algae the opposite direction. See, right now the water's going up against gravity, right? And so the algae is like falling out and collecting on the bottoms of the tubes. So I want to run the algae the other way so that gravity's helping it flow along the tubes. Another thing that people have recommended is maybe have just 2 sheets of glass with space. Basically make a really thin fish tank. That way I don't have so many inlets, just have one inlet, greatly simplify it, use less materials. The problem with that is chicken hole base is going to be pressurized. And even a little bit of pressure over a wide area, that's going to build up to a lot of force. I imagine glass would just break under such stress. Maybe I could use tempered glass, which is stronger. It's more expensive, but that's an option. And I think I will try it, but in order to mitigate the pressure effects, I'm thinking maybe have like some spacers glued kind of in the middle of the glass panels. Maybe something that goes all up, way up it, so it's effectively tubes, but they're kind of squarish. That way the pressure's not got so much leverage, you know. And if that doesn't work, maybe I will just get glass tubes. The electronic system, that all works great. I might use a different thermostat, and better housing, but yeah, that design, that works great. The solar panel and everything, I love it. And the best part is, I only need one. I could use that to trigger all of my algae panels. If I had 50 panels, I only need one electronic system. Anyway, let's get working on the next iteration. We're gonna go the flat panel route. I'm gonna see if I can find some pieces of glass. Let's see what we can do. So it's been a while, and as you can see, I've dismantled and removed the old panel, but I've just got done building the new prototype. Now this one's not full scale, it's just a smaller version so I can test out the fluid physics and stuff. But let me go through it with you real quick. So where to start? Here's an air pump, which I'll probably mount on there a little bit better at some point, but it's pumping air down into this chamber here, and this is where the algae will sit at night or when it's too cold. This is its protected space. Now this chamber here has got 2 parts. So there's this outer envelope, but there's also like a bell-shaped piece inside which is capturing the air that's coming up. See that? So the air stream splits in 2, one goes off to the side, that's just to keep things stirred, but the main bulk of the air goes through into this bell, gets captured, and then funneled into this tube here, which sends the air down into this tube, into this chamber. Now this chamber here has got a pump which will pump brine, a salty water mixture, up through this tube into here and fill it up. Let me actually plug in that pump so you can see this happening. So it's pumping the brine in, and now that the brine's here, it's heavy, and the air going through this tube is stopped. And that causes the air to build up over here, and it forces down on the liquid. And when the liquid inside of this bell is forced down, it's forcing the water in the rest of the system up, and thus filling the algae panel. You can see the liquid level in here slowly rising. And once this is completely full of brine, there's an overflow here, so the brine can be circulated back. You can see it's dumping out in there. And the brine just keeps circulating. And on the full-scale version, this will go into a coil going through the algae to pull heat out of the algae, and then I'll have this go through a radiator to exchange heat with the air to get rid of that heat before circulating back. Because remember, the sun is putting 1,000 watts per square meter roughly into the algae, and I've got to get that heat gone somehow, otherwise it'll get too hot and kill the algae. Okay, so the algae panel's almost full. There it is. See the liquid level's still rising up through this tube. There we are. So now it's completely full. You can also see that the air is starting to be able to come through the brine now, so it's reached the maximum internal pressure. So what's going on here is this overflow chamber. The air is now, at least most of it, is coming up. I've got a little deflector here to get the bubbles to go off to the side so that the bubbles don't go back into the panel. Those bubbles are coming out of this tube here. So this is just the main vent. But as the bubbles rise up, they trap water ahead of them. And so it's pushing a slug of water up through into this chamber here, raising the water level. But as the water level raises, it's going to want to overflow into the panel. So it's going to create a circulation to keep the algae flowing. Let's actually take off this vent here. And I'll add a little bit of dye so you can see what's going on. It's green for algae. So we put in a few drops of that. You can see the green is moving through into the panel. It's actually interesting to see how this is flowing. May have to optimize this a bit, but you see the dye goes through. It's being pulled down. You see the green is coming up into this chamber and is circulating all the way back through. In fact, very soon you'll probably be able to see this turn green. So that's how it operates. So now, let's say it gets cold, nighttime, the sun's no longer shining, there's no reason to have it out exposed in the panel, so have the pump turn off. So now the brine gets sucked back into the lower reservoir. Bubbles are able to escape, and this water level here is able to rise. And as it rises here, it goes down over here. So it's leaving the panel. The algae's going home. There it is. It's all out of the panel. It's all back to safety. So what I like about this design is it's only got two moving parts besides the liquid. The air pump, which runs continuously, and the brine pump, which just moves the brine to trigger the algae to flow into the panel. If the pump fails, then the algae will just sit happily inside of its chamber where it's kept safe. If the pump fails, then actually, let me test that. Let's get this running again. Let's see what happens when the air pump fails. Okay, panel's full again. I'm going to unplug the air pump. I'm going to leave the brine pump on. So the brine's still circulating, but the air is stopped. Now, the air isn't moving. It's trapped in here. So that's taking up volume and the algae has stopped circulating. There's nothing pushing the water anymore. That's a problem because now it'll sit here in the sun and overheat, and that'll kill a large volume of algae, everything that's in the panel. So for the full scale, I need to make sure I've got like a small capillary tube for the air to escape, you know, just like a little bypass, so that when it shuts off, the air can still get out. Or at the very least have something that if the air stops moving, it'll also turn off the brine pump, so the air can release the algae from the panel. Alright, so that's one of the reasons I built the smaller version, is so I can see problems like that occurring. There's another problem here, which I'll have to fix, is algae gets stuck inside the tube. And if the algae sits for too long, it will coagulate, especially the spirulina. It clumps together and that could cause it to plug up, so it needs to always be moving. So I need to also have another little bypass up here to connect to here, so that when the panel's off, the algae can still circulate a little bit through the tube. Probably have all that portion like inside the insulated space so it doesn't freeze. But that way, you know, there's nowhere for the algae to sit and cause a clot to form. Yeah. Definitely if the power goes out, it'll just shut off and the algae will go back into the chamber. That's not a problem. So as you can see right here, normally the brine siphons out, but sometimes the siphon gets stuck, like an air bubble gets into the tube and it stops the siphon from happening. So you can see there's a little bit of fluid dripping out, so it will over time. Yeah, so this last little bit of brine will eventually leave. It's not really a problem if a little bit gets stuck in here, but anyway. Now to go build a bigger version of this. I'll probably cut the video here because it's going to take me a while to get the larger version built, and I guess that could be another video. Hope you enjoyed. I'll see you then.